Okay, this how-to video is going to talk about how to use the cross-section editor inside the Cadence PCB tools. The cross-section editor or stack-up generator is where you would effectively define the layers of your PCB, the number of layers that you want. You would build this as you would actually build a PCB, so between every conductor material you would have a dielectric piece of material, whether that be FR4 or a pre-preg bit of material, and you can define all that in the cross-section editor. We actually use two material files. There's a materials.dat or CMX file, which is where you store all the default materials for that, and then there's something called a site file, materials, a layer materials.xml file, which stores if you're building mask materials, so if you wanted to include things like silk screens or cover lays or any specific coatings that you need for flexi-rigid style designs, and I'll show you how to edit both of those files as well. So initially, if you look at setup, more materials, this is where we store all the default materials. This is the material.cmx file. This is stored in your material path location, and I'll show you how to set that in a minute. So these are all the default materials that are supplied with the Cadence PCB tools, and I can obviously do a right mouse button here, create new, and customize this and add my own materials as I need to, or edit any of the ones that I don't need to go along. And you can specify kind of a layer, function and design type, and then the physical rules, and then the electrical rules for each material as you go along. This is stored in your user preferences, so setup, user preferences, paths and config, and there's one called material path where you would specify that path location. The other one is available from the cross-section editor itself, so let's launch the cross-section editor. We can either access it from the icon, we can type X section or at the command line, or we can assign a shortcut key to that. We can also get it from the setup cross-section menu command. So this is the default starting point. We always start with a two-layer board. You can see I've got two conductors and a piece of dielectric in between that, and you can then come and customize layers to suit as you go along. So we can add layers several ways. So I can do a right mouse button, add layers. This would give me a wizard style option. I can do a right mouse button, add layer pair above, which would add effectively a single layer and a dielectric. I can do a right mouse button, add layer above, and it would add just a single entry, add layer above. So I'm adding the dielectrics manually, and I can then go and then choose what I want to do. Let's just get rid of those. So right mouse button, remove layer, and you can remove layers when you want to, as long as there's no copper items or text or anything like that on those specific layers at the time. Let's use the right mouse button here, and we'll do the add layers option. So you can see I can count the number of new layers. So maybe if I wanted to add 3 more layers, I'm not going to add a prefix, but you could add a prefix. Let's add them below the selected dielectric, choose a conductor and click on add. That would effectively then add the next 3 layers in, so I've now got effectively a 6-layer PCB. The layer names themselves are customizable to whatever you want, apart from the top and the bottom. These are kind of fixed as top and bottom names. The rest of the names you can type in pretty much what you want. So we'll call this one inner 1. Let's call this one flex 1. Flex 2 and inner 4. So I've then effectively built my 6-layer board. I'm going to have a multiple stack ups option here on this PCB, and I'll show you how to do that in a minute. We then can choose kind of what we want our layer function to be. So conductors can either be a conductor or a plane, and you've also got the dielectric for in between each object. You can have copper pores and tracking on any of the electrical layers and the conductor layers. The main reason the difference between the two is if you're using any signal integrity or impedance checking, etc. like that, you would need to have some plane layers for it to reference to. The conductor type, the dielectric type materials can be chosen, so you can actually have dielectric cores or dielectric prepregs depending on the specific function that you want. So you can build the stack up as it actually would be properly on a PCB. So we could effectively make this a dielectric core. This could be effectively a bit of prepreg. This would be then a dielectric core. So you could build the stack up as you wanted to. It might be worthwhile talking to your PCB fabricator to kind of get the correct stack up that you wanted to do. The same for the copper materials. You can obviously have copper foil for the outer layers. So maybe I wanted some copper foil on the outer layers because you would then plate up on the outer layer. So let's put copper foil for both of those. And then you can have these as a specific weighted copper if you have specific copper choices. So you can build the stack up directly as you want. You can actually get a lot of this information from the PCB fabricator as well if you wanted to, so it's worthwhile having a chat to them. You can obviously export these files, so there's export cross-section technology file, and we can import a cross-section technology file. This means that you can reuse or you can make stack ups and then reuse them over and over again. So make a 4-layer technology file, a 6-layer technology file, whatever you require. If you talk to your PCB fabricator and they're using the latest version of Polar Instruments, they can actually export an IPC 2581 file, which you can import, and that would then bring in the cross section, so all the different layers and all the type materials and the relative electrical properties that come with the layer information. So you can use that going forward, which may save you some time setting up a cross section. If we start to expand out some of these options, so we can expand out, say, the thickness and see the specific thicknesses. So you've got a value, you've got a tolerance of that for the thickness options. The physical options allow you to do things like define if you're using a negative artwork or not. If you want to use the pad suppression option, there's also a signal integrity option where you can start to define and use it to calculate some of your differential spacings or what differential rules you want to use. So it's worthwhile looking at those if you need to calculate that type of information, but it's all stored within the cross-section file. If we need to add more layers, we can obviously, there's an edit site file, which does allow us to build in things like any adhesive type layers or silkscreen layers or solder mask layers if they're not there by default. So this site file is also stored, so it's a mask layer site file.xml. This is also stored in your material path location, and it would use that to add to drive the materials when we add more layers. We can click on add to build this, and that would then allow us to go and build a specific type, and you can pick the material type that you want it to use, put it in the name, the surface finish, etc., and the defined material that you want to use. So to add layers, I can also use the right mouse button, add layers, and I can start to build mask layers to this. So under the design based options, I want to add things like a solder mask, so I can actually add, if we look under the design defined mask layers, Cadence supply a solder mask top, so it's solder mask, and I'm going to pick the material that I want to be the flexible LPI, and we'll click on add. Let's add that above, and we'll click on add. That would then effectively add my solder mask top layer. Let's just drag this to see the text. We'll then select the bottom and we'll do above the surface, and we'll add a solder mask bottom using the same material. Add, so that builds my solder mask into my stack up. I'm actually getting the material, the thickness, and all the relevant material information that I need, so I would start to get a more accurate stack up cross-section thickness. If I want to add things like adhesives or cover lays for the flexi part of the PCB, we can add those here as well. So you can see there's a cover lay top and bottom, so let's add a cover lay bottom. We'll just add that to the bottom. We'll then go and select the top, and we'll add a cover lay top, and we'll just add that to the cover lay top. Let's add some stiffener, so maybe I want a stiffener top, and we'll add the stiffener top, and I'll probably need some adhesive as well. Now the adhesive doesn't come as a default designed layer, so that would be in the site defined mask layer files. This is something you may have to define yourself, but I've obviously got some up here, some I've prepared earlier. So there's an adhesive top layer there that we'll add there. That then starts to build up the stack up, and you can see the stack up changing every time I do any of this. Once you're happy with the layers that you've got, you can then start to maybe drive a multiple stack up option. So if we go to the edit, the view menu, and it's multiple stack ups mode, this then enables the multiple stack ups mode. So I have a primary, and I can then go and add a new layer or a new stack up mode. So I'm going to call this flexi. I'm going to exclude all the copy layers, but you can actually copy all these options already, and we'll click OK, and then that would leave all these unchecked, and I can then go and drive the layers that I need for my my flexi section. So I would need the 2 flexi layers and the dielectric material, and I'd need the adhesive, the stiffener, and the cover lay on the bottom. But I don't need those in my primary section, so I can actually undo these from my primary section. So you can actually see this is physically updating. We can then apply that, and I've now got an updated graphical representation, and you can see there's my inner part of the flexi with the mask layers that I need. If I'm happy with that, I can look at maybe locking this, so I can actually lock the cross section from being added. There's an option info, which gives me the thickness, and if I look at the primary, that's the main thickness of the primary. Look at the flexi, these values will actually update and show me that. When I hit apply and OK, if I then go back to the visibility pane, these layers have physically been added to my cross section. So if I look at the primary or the flexi, I can actually get these updated and showing me.